So let's look at this force vibration equation from before. And we're first going to look at the undamped case. So undamped means this damping term is going to go away. So we'll have mu double prime plus ku equals f naught cosine of omega t. And how are we going to solve this? We need to use the method of undetermined coefficients. So first we're going to find the homogeneous, the solution to the general solution to the homogeneous case. So that's with the right side being 0. And remember when we did the oscillator when the right side was 0, we had this omega naught equals the root of k over m thing. And we'll see that come into play in a second. So we have the characteristic equation is mr squared plus k equals 0. So r squared is negative k over m. And remember that k and m were both positive. This is the spring constant. This is a mass. So in real life, they're both going to be positive. So then when we solve for r, we're going to get a purely imaginary number, plus or minus the root of k over m I. And then if w naught was k over m, this just made our writing a little bit easier. It was plus or minus w naught I. Okay, so no real part, which means when we write the general solution to the homogeneous case, we're not going to have e's. We're just going to have cosines and sines. Take the imaginary part, put it there, plus c2 sine omega naught t. Okay, that was the general solution, and now we're going to guess a particular solution, and we'll add it to the general solution, and then that'll be the general solution to the non-homogeneous case. This is the particular solution to the non-homogeneous case, which is what we're trying to solve. Method of undetermined coefficients says we go over here, we see a cosine. This is just a constant. F naught and w or omega were constants. So we just see a cosine, which means this needs to be a linear combination of sine and cosine, and the thing in here goes in here, plus b sine omega t. Okay, that's what we want to guess, and most of the time it works. The only time it doesn't work, because we need to check if any of these terms are repeated here. So it really, really matters whether omega equals omega naught. And that just depends, because omega is some random constant given by the outside forcing, so we don't know what that's going to be. If that happens to be the root of k over m for your spring and your mass, then you're going to have a different solution. So big question that you always check is, does omega equal omega naught? Okay, so we're going to do an example where omega does not equal omega naught. So let's actually get some numbers here. So u double prime plus 25 u equals cosine of 3t is going to be the example. And we'll actually make it an initial value problem so we can solve it all the way. U of 0 equals 0. U prime of 0 is also 0. So we have a thing starting at rest in what we've defined to be a neutral position. Okay, so we're going to do a little bit of the same stuff as up there again. We'll find the general solution to the homogeneous case. So the differential equation we're looking at here is u double prime plus 25u equals 0. Just do this quickly. Characteristic equation is r squared plus 25 equals 0. So r is going to end up being plus or minus 5i. General solution will be u of t equals c1 cosine of 5t plus c2 sine of 5t. Again, no real part, so no e to some power. We just have the trig functions. Okay, and then we need to guess the particular solution to the non-homogeneous case. Method of undetermined coefficients says go over here. We see a cosine, so we need a linear combination of sines and cosines. So we'll guess u of t equals a. Doesn't matter. I'll do it the same as my scratch work so that I don't make mistakes. A cosine of 3t plus b sine of 3t. We check none of these terms are in my general solution to the homogeneous case, because that's what omega does not equal omega naught gives us. So we can use this guess. We now need to plug this back into the original to solve for a and b. Okay, so u prime is, let's see, this is going to be negative sign, and we get an extra 3 on the outside from the chain rule. And then this is going to be positive cosine, and we get an extra 3 outside from the chain rule. And then we differentiate again. This is going to be cosine, keep the sign the same, and then we get another 3, so 9a cosine 3t plus, minus, because derivative of cosine is minus sine, get an extra 3 again, 9b sine 3t. Okay, and now we plug this into the original. So we'll have 25 times this thing plus this thing. I'm going to write the 25 times this thing first so that I don't have negatives out in front in my equation. Okay, so I get 25a cosine 3t plus 25b sine of 3t. And then this is my u double prime, minus 9a cosine 3t minus 9b sine 3t. And then the right side was cosine of 3t. Now these are nice. The a always stays with the cosine, and the b always stays with the sine. That is the nice thing about the undamped case, is we don't have u primes, we only have u double primes. So that does make our life easier. So we have 25 minus 9 of those is 16 a cosine 3t plus 25 minus 9 of those, 16 of those, b sine 3t equals cosine of 3t. This equation has to be true for all values of t, so we can just compare coefficients. The function over here has to be exactly the same as the function over here. So 16a equals 1 is in front of cosine 3t, and 16b equals, over here we don't have a sine of 3t, so 0 in front. So this gives us a is 1/16 and b is 0. So our particular solution is then u of t equals a was in front of cosine 3t. You can look back and check if you want. And then b was in front of sine 3t, but it's 0. So that's the particular solution. So now we can get a general solution to the non-homogeneous case by adding this to the general solution to the homogeneous case. And so u of t is c1 cosine 5t plus c2 sine 5t plus, and this thing, 1/16 cosine 3t. Okay, now we can use our initial conditions, which I will rewrite here, to solve for c1 and c2. Okay, so u of 0, we can just put 0 in for t. Cosine of 0 is 1, so this whole thing is c1. Sine of 0 is 0, so this term drops off. Cosine of 0 is 1 again, so plus 1/16, and that's supposed to equal 0. So then c1 must be negative 1/16. Okay, I need to take a derivative to use the second initial condition, so let's do that. Derivative of cosine is negative sine, and I get an extra 5 in front from the chain rule. Here, derivative of sine is positive cosine. I also get a 5 in front from the chain rule. And derivative of cosine is negative sine again. This is negative. I get an extra 3 in front from the chain rule. Okay, now I can put in 0 for t. Let's see. Sine of 0 is 0, so that whole term goes away. Cosine of 0 is 1, so that whole term is 5c2. Sine of 0 is 0, that whole term goes away. And that's supposed to equal 0. So this is easy, c2 equals 0. So now we have our unique solution given the initial values. U of t equals c1 is minus 1/16 cosine of 5t plus 1/16 cosine of 3t. Okay, now what does this look like in a graph? I have no idea, because the periods of these are going to be different. We have cosine t. Cosine 5t is going to be a lot denser than cosine 3t. It's a little less dense. And then what happens when I subtract them and multiply by 1/16? No idea. So this is where the trig formulas come in, and I would like to be able to write this sum or difference as a product. So multiplying and graphing is a little bit easier. So how can I do that? I need my trig formulas. So cosine of A, I'm using little a and b because I used big A and big B already, was cosine A, cosine B minus sine A, sine B. Cosine A minus B was cosine A, cosine B plus sine A, sine B. And these are in the 4 formulas that I would encourage you to memorize because they're easy. The other ones are harder to memorize, so we're going to derive them from the easy ones to memorize. Okay, there's a minus sign here and a plus sign here, so we're going to subtract. Let's subtract this way so that things end up being more positive. So cosine A minus B minus cosine of A plus B is, and then I get these guys cancel, and I get this one minus negative of the same thing, so I get 2 of them, sine A, sine B. Okay. What do I want? I want A minus B to be 3t, and A plus B to be 5t, and I'll have a 1/16 out in front. So now I can solve for A and B. So if I add these 2 equations together, the b's cancel, I get 2a equals 8t, so A must be 4t. And then if I take the bottom one minus the top one, I get 2b, the a's will cancel, equals 2t, so b equals t. So what ends up happening is I get sine of 4t and sine of t, and there's a 2, and there was a 1/16. So in total, when those multiply together, it's 1/8. So another way of writing my solution, I already had the solution, but I'm going to write it a different way so it's easier to graph. I said 2 times 1/16, right? So that was 1/8, and it was sine of 4t times sine of t. That's what the a and b came out to be. This one I can graph. Okay, so let's just look. Sine of t, I think, is going to be the compressed one. Let's see. We have 4t. Sine of 4t is going to be the compressed one, sorry. If we go from 0 to 2 pi, then t is going to go from 0 to, if I make 4t equal to 2 pi, then t is pi over 2. Okay, and then the sine of 4t goes through all the values, but it starts at 0 and ends at 0. It's going to go through all the regular values. Okay, so period of this one is pi over 2. Period of this one is 2 pi. So let's draw the bigger one. This is my t-axis and my u-axis. Let's see, this is 0. We're drawing the bigger one. Let's incorporate the 1/8. So, yeah, okay. We'll make it small just so that we see what this is. So if that's 1/8, then this thing is going to be way too big. Because here's, all right. Yeah, it's fine. 1, 2, 3, 4, 5, 6, 7, 8. That's 1. This is 1.5. So a little bit more than, yeah, another 4 was 1.5, right? A little more than 1.5. 1.57. Each one of these is 0.125, so 1.625. So about halfway. This is pi over 2. Okay, so here's the big one. We are going up to 1/8 in that time. Oh, this is going to be terrible to draw. All right, we will try though. Okay, so we're going up to 1/8. And then we'll come back down in that amount of time. And then I'm going to draw this thing underneath as well, which does the same thing, up and back down. And then what's going to happen is my sine of 4t with a period of pi over 2, so here we need to go up, down, and back in that time, is going to be enveloped by this thing. So normally I would go up to 1 and then back down. But now when I multiply it by this, I make everything smaller actually. Let's see. Can I go, what's half of that? About 0.8. This is 0.75. Okay. So I need to go to here. I need to come down and touch this curve somewhere, and then come back up in this time. That's what that looks like. And then I keep going. This curve changes. Like this is going to come down here. So this changes. Let's see, where does it come down? It comes down at pi. So I've actually gone through a whole other period of this by the time it comes down to pi. So this is not to scale anymore. But they should land at the same period. So if I were to draw this, if I were to have a more extreme example, I might have this orange curve be pretty big. Right, here's the other curve. And then I might have a thing. So let's see, I was hitting a full period by here. So my other curve might look like that. Sorry, I need to actually go back up and down by this time. And then I need to go down and up and back down by this time. And then I go through. By halfway, and then down and up and back down. Okay, so what does this mean? This is called beats. So this whole undamped case where omega naught does not equal omega. Omega naught is kind of the natural vibrating frequency, and omega was the forcing frequency, right? The reason it's called beats, you can actually hear it in music. If you have, they tune to A with a frequency of 440 hertz. So if someone's in tune, exactly in tune, and then you hear someone else play an A, but they're a little sharp, they're at 441 hertz. So what happens is you actually see this. So it's like our 440 is 3T, and our 441 is 5T. So what happens is you see the average. We saw that in the 4T. So what you hear is you hear 440.5 hertz. That was the sine of 4T curve. But it's coming in and out. There's like a bigger frequency. And then the subtraction, let's see, this was, yeah, subtract and then divide by 2, actually. So 1 divided by 2. So we have a 1/2 second bigger frequency here. So what you're going to hear is you're going to hear this note, which is not as out of tune as this one, so closer to the original 440. And you're going to hear it pulse. So you get louder and quieter every 1/2 of a second. This actually happens in music, where the out of tune guy is forcing the other guy, and then you hear this result.